A very good day to one and all. I, Bhavisheshwar, from the Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli, is presenting my paper titled ASocTweetPred, Mining and Prediction of Antisocial and Abusive Tweets for Antisocial Behavior Detection using Selective Preferential Learning. And the co-authors and the mentors for my paper are Dr. Gerard Deepak, Assistant Professor, Manipal Institute of Technology, Bangalore, Manipal University, Manipal, India, and Dr. Mala, Professor, National Institute of Technology, Tiruchirappalli. Abstract. Mining and prediction of antisocial and abusive tweets is the need of the hour. In the present times, owing to a large number of social interactions via online social networking platforms, because the content is not moderated on the World Wide Web, especially on the social web due to the lack of moderation, there are many derogatory, antisocial, and racist comments. Specifically, Twitter, YouTube, Instagram, Facebook comments, and similar social network platforms. In this paper, ASocTweetPred for mining and prediction of antisocial and abusive tweets for antisocial behavior detection has been put forth. By encompassing ontologies of different phases, knowledge graph, and the classification of dataset using the LSTM to generate and yield matching ontology snippets by computing the semantic similarity using the Bose-Einstein's index and the APMI measure. Subsequently, the matched ontology snippets and the formulated knowledge graph are used in order to extract features by preferential selection using Shannon's entropy and Horn's index with differential step deviation measures. A triadic hybrid model of the LSTM bagging with random forest and SVC and XGBoost classifiers are made use for the antisocial tweet prediction. As a result, the ASocTweetPred achieves an overall precision of 97.93%, a recall of 98.09%, accuracy of 98.01%, F measure of 98%, and with the lowest FNR of 0.02, making it an efficient and semantically compliant framework for the antisocial tweet detection. Motivation. The lack of knowledge-centric frameworks for antisocial tweet mining and prediction to detect antisocial behavior on online social networking platforms, which incorporates semantically inclined machine intelligence driven framework with hybridized machine learning models with ontology focus. With the structure of the World Wide Web moving towards Web 3.0, a knowledge-centric antisocial tweet prediction framework is required to scope the cohesive semantic structure of the Web 3.0. Contribution. The proposed ASocTweetPred has the following novel contributions. Using the LSTM, classification of the dataset is done. A knowledge graph is created from the crawl tweets containing the recognized abusive phrases, the Bose-Einstein's index, the APMI, differential thresholds, and the step deviation metrics are utilized to compute semantic similarity. Using the hybridized triadic classifiers, the model was trained using the matched ontology snippets and the knowledge graph produced in the two different phases. The model was trained using the LSTM, bagging with random forest and SVC and XGBoost, as well as feature selection using Shannon's entropy with Horn's index and differential thresholds. In the proposed methodology, as compared to the baseline models, precision, recall, accuracy, and F measure are raised, and the overall FNR is decreased. Literature survey is depicted as follows. Although several papers were used for literature survey, the four important papers have been discussed here. Chowdhury et al. Have proposed the TTRO plus LSTM framework, which computes a hate map and only collects data that has got racism. Singh et al. Have put forth an antisocial behavior analysis framework using CNN with glove combination. And Ventirosas et al. Have proposed a model which detects aggressive behavior and discusses threats using the text mining model. Singh et al. Have developed a deep learning model for antisocial behavior analysis of social media, which uses data collected from Swarm and Twitter. Knowledge was augmented from Twitter and Swarm using their respective APIs. Four different deep learning models were also utilized. And the major gaps included absence of knowledge led to underfitting, deviation in reasoning, absence of regulatory mechanism for auxiliary knowledge, and the other gaps were no semantically inclined framework suited the Web 3.0. Proposed architecture. The figure depicts the phase 1 and the phase 2 of the proposed framework. So the phase 1 indicates knowledge graph of the tweets containing the abusive words is formulated with the fragments of the abusive words and the context of the tweet. The Twitter API is used to yield the tweets of abusive words, and also the tweets were crawled using the customized crawler. Phase 2 is the formalization of the distinct pools of ontologies, that is ontology of conspiracy, ontology of aggression, ontology of criminology and crime, curse words ontology, and ontology pool of threats. The ontologies are yielded through two distinct frameworks, OntoCollab and Startup. Subsequently, the dataset is classified using LSTM, a deep learning classifier. It is classified individualistically using LSTM to handle the large volumes of the data in the dataset. Then the classes of the dataset are used to compute the semantic similarity with that of the indexed, annotated, and pool of ontology. Semantic similarity is computed using the Bose-Einstein statistic distribution and the APMI machine, which ensures that the best-in-class matched ontology snippets are obtained. The figure depicts the phase 3 of the proposed system. At the end of the phase 1, a formulated knowledge graph with abusive words was yielded. At the end of the phase 2, a matched ontology snippets were yielded, which are further used in the phase 3 as primary inputs, and in order to compute the feature selection, Shannon's entropy and Horn's index are used, with the variational feature selection step deviance. The selected features are only passed to the machine learning classifier, namely bagging and XGBoost classifiers. So the model used for the training is a threefold hybridized model comprising the LSTM. The deep learning classifier does not require a manual feature selection but automatically select features. For bagging and XGBoost, the features selected using Shannon's entropy and Horn's index combination are yielded. So the threefold model comprises the bagging classifier and XGBoost classifier and the LSTM. The model is trained using the matched ontology snippets and the entities discovered from the knowledge graph. Several orders of Twitter datasets are passed into the trained model, and the antisocial tweet prediction from the dataset is predicted. Implementation. The language used was Python. The IDE was Google Collaboratory. OntoCollab and Stardark are the two distinct frameworks used for ontology modeling. The two individual datasets are the Antisocial Behavior Public Twitter Indonesia dataset and Twitter Sentiment Analysis Hated Speech dataset. The two individual datasets were integrated to a single large dataset. The proposed ASocTweetPred was implemented using Google's Collaboratory IDE in an Intel Core i7 computer with a RAM of 32 GB and a clock speed of 3.6 GHz. Python's NLTK framework was employed for carrying out language processing tasks. Matplotlib was used for plotting, and WordNote 3.0 was used for carrying out the lemmatization and the lexico-syntactico-grammatical tasks. Result analysis. Precision, recall, accuracy, F-measure, FNR are the major measures used for the comparison of the proposed model with the baseline models TTRO plus LSTM, ABADL, DABDT, DLA-BSM. Similar models were considered as the baseline models, and the proposed ASocTweetPred achieves an overall highest average precision percentage of 97.93%, average recall of 98.09%, accuracy of 98.01%, F-measure 98%, and with the lowest value of 0.02. The precision, recall, accuracy F-measure compares the relevance of the results, whereas the FNR computes the false negative rate. The reason why the proposed ASocTweetPred performs best is because the framework is knowledge-centric, aggregative, and ontology-focused, with a strong knowledge regulatory mechanism and a robust semantic similarity as well as the step deviance computation. The similarity index computation mechanism is hybridized. Due to these reasons, the proposed ASocTweetPred outperforms the compared baseline models. The reason why the TTRO plus LSTM model does not perform as expected is there needs to be much more variety of auxiliary knowledge to be supplied. The reason why the ABADL model does not perform as expected is the CNN with the glove model did not work due to the lack of augmented knowledge and a lack of knowledge regulation schemes. There were no robust knowledge regulation mechanism in the framework and the regulation mechanism was absent. Owing to these reasons, the DABDT framework does not perform as expected to the proposed ASocTweetPred model. In the DLA BSM model, the learning was robust, so it had underfitting of data, and the only deep learning classifiers means it also learned outliers in the dataset. So the knowledge had to be regulated and surpassed into the framework. The figure shows precision versus number of arbitrary classified instances over a range of 10 to 50 instances for the proposed ASocTweetPred and the other baseline models. We can clearly see that the ASocTweetPred model yields the highest precision percentage when compared to the baseline models. Conclusion: the ASocTweetPred framework has been put forth for antisocial tweet prediction and mining of antisocial tweets to detect antisocial behavior on the Twitter platform. Several perspectives of ontologies like the ontology of aggression, crime curse word ontology, and the ontology pool of threats were integrated and used the standard index to yield sufficient auxiliary knowledge. Subsequently, a knowledge graph is formulated from the crawl tweets with the identified abusive words. Semantic similarity is computed using Bose-Einstein's index with the APMI with differential thresholds and step deviation measures. The dataset is classified using the LSTM classifier. The matched ontology snippets and the knowledge graph yielded from phase 1 and 2 were used for preferentially selecting the features to train the model using the hybridized triadic classifiers, namely the LSTM backing with random forest and SVC and XGBoost for training the model, and Shannon's entropy with Horn's index with differential thresholds were used for feature selection in order to train the model. The proposed ASocTweetPred framework achieved an overall precision of 97.93%, recall of 98.09%, accuracy of 98.01%, F measure of 98%, and with the lowest FNR value of 0.02. These are the references used for the paper. Finally, I would like to thank everyone for providing me this opportunity to present my paper.